Hello everyone, welcome to my channel. Today I will explain CMOS, CMOS working principle, advantages and disadvantages. What is CMOS? CMOS stands for complementary metal oxide semiconductor. It's a technology. It is the cornerstone of modern electronics, enabling the fabrications of high density, low power integrated circuits. This overall will cover the basics of CMOS fundamentals, including its structure, operation, and applications. What is CMOS? CMOS technology uses both PMOS and NMOS transistors to create logic functions. The complementary nature of these transistors allows for low power consumption and high noise immunity, making CMOS as a preferred choice for digital circuits. In this slide, the main advantages of CMOS over NMOS and bipolar technologies. Bipolar technology means that is BJT technology is the much smaller power consumption. Unlike NMOS or bipolar circuits, complementary MOS circuits has almost no static power dissipation, and the performance of this CMOS technology is higher than the other technologies. Uh, the complementary metal oxide semiconductor transistor consists of both PMOS and NMOS. Please, you can refer below link to know about more about this. This is the master structure of NMOS and PMOS, where we have taken P substrate, and for PMOS we will add N will, then we will there will be source and drain for NMOS, then source and drain for PMOS. There will be body for both NMOS and PMOS. There will be gate in both NMOS and PMOS. NMOS N-type metal oxide semiconductor. Uh, NMOS transistors are made with N-type semiconductor material, which has an excess of electrons. NMOS transistors are activated when high voltage, that is, one is applied to the gate, allowing the current flow between the drain and source. NMOS transistors are generally faster and more efficient than the PMOS transistor due to the higher mobility of electrons. As shown in the slide, this is the structure of NMOS. NMOS is a built on P-type substrate with an N-type source and drain. When high voltage is applied to the gate, NMOS will be conducted. Similarly, when a low voltage is applied to the gate, NMOS will not conduct. Uh, NMOS is considered to be the faster than the PMOS since because the mobility of electrons is high. Therefore, the NMOS is faster than the PMOS. Then PMOS transistors. PMOS transistors are made with P-type semiconductor material, which has a deficiency of electrons. That means there will be more number of holes will be there. The PMOS transistors are activated when low voltage is applied to the gate, allowing current to flow between the drain and source. The PMOS transistors are generally slower than the NMOS transistors due to the lower mobility of holes. As shown in this slide, P-channel MOSFET consists of P-type source and drain diffused on the N-type substrate. The majority of carriers are holes. When high voltage is applied to the gate, the PMOS will not conduct. When low voltage is applied to the gate, then the PMOS will conduct. The PMOS devices are more immune to noise than the NMOS devices. CMOS working principle. In CMOS technology, both N-type and P-type transistors are used to design the logic function. The same signal is that turn on one type of transistor is used to turn off the other type of transistor. The CMOS technology enables the design of logic function using simple switches, eliminating the need for complex circuits and reducing the power consumptions. As shown in this slide, this is CMOS using pull-up and pull-down transistors. Pull-up is PMOS transistor, pull-down is NMOS transistor. This is PMOS transistor. This always it will pull output to the high, but in NMOS it will pull to the low. Then actually, if both p-type and n-type transistors have their gates connected to the same input, then there will be p-type MOSFET will be turned on, and n-type MOSFET will be turned off, like versa. This is how one transistor is on and another transistor is off. The CMOS offers relatively high speed, low power dissipation, high noise margin in both states, and will operate over wide range of source and input voltage. This is the CMOS inverter where PMOS connected to VDD and MOS is connected to ground. The inverter circuit shown in the below figure. The NMOS transistor is input from VSS. The PMOS transistor has input from VDD. The terminal is Y is output. When high voltage is given at input terminal of inverter, PMOS become as open circuit and MOS switched off so that the output will be pulled down to VSS. Then when low voltage is applied to the inverter, the NMOS switched off, PMOS switched on, so the output becomes VDD. The circuit pulled up to VDD. The truth table as shown in this table. Uh, yeah, this is the CMOS structure of NAND gate, whereas the PMOS is both PMOS is connected in parallel and both NMOS is connected in series. When if the input is 0 1, then output will be high. The input if both inputs are 1, then output is pulled to ground. The either one input is 0, then output will be high. This is the truth table for the NAND gate. If the both inputs are 0 0, then a pull down network will be off, pull up network will be on, and then output will be high. If the both inputs are 1 1, then pull down network will be on, pull up network will be off, therefore the output will be 0. If the either one input is 0, then output will be high. CMOS fabrication. The fabrication of CMOS transistors can be done on the wafer of silicon. The diameter of the wafer ranges from 20 mm to 300 mm. In this, the lithography process is the same as the printing press. On every step, different materials can be deposited, etched, otherwise otherwise patterned. This is the process is very simple to understand by viewing the wafer top as well as cross section within the simplified assembling method. The fabrication of CMOS can be accumulated through the using three technologies, namely N-well, P-well, twin-well, and SOI, silicon on insulator. These are the characteristics of CMOS technology. Basically, it has low power consumption and high noise immunity, high density, high speed, and low voltage operation. These are the characteristics of CMOS technology. Then advantages of CMOS. Basically, it has low power consumption. CMOS technology is known as for its low power consumption, making it is an ideal choice for better powered devices. And then high noise immunity. The complementary nature of CMOS transistors provides high noise immunity, reducing the uh, likelihood of errors in digital circuits. High density CMOS technology enables the fabrication of high density ICs, allowing for complex digital systems to be integrated onto single chip. Disadvantages of CMOS technology. While CMOS technology has many advantages, it also has some disadvantages that need to be considered. Some of the main disadvantages of CMOS technology are there will be exist latch up issue. CMOS circuits can be susceptible to latch up in condition where high current flows between power supply and ground. Then ESD, electrostatic discharge sensitivity. CMOS circuits can be sensitive to ESD, which can cause damage to transistors and other components. There will be manufacturing complexity, yield issue, design complexity. These are the disadvantages of CMOS technology. CMOS applications. CMOS technology has been used for the following digital IC designs, then computer memories, CPUs, microprocessor designs, flash memory chip designing, used to design Apple ASIC chips, then mixed signal circuits. These are the applications of CMOS technology. Thank you for